This question is asked in one of the Taiwan Olympiad exam. It's a very difficult and challenging question because if you put this question on Chat GPT, Math GPT, wherever, they will not able to solve this. Let's solve this problem. The problem is, first understand the problem, that a charged particle of charge q and the mass m enters in this region with some speed perpendicularly on this mn, that is given. This side the magnetic field present is upward and its value is b1. This side the magnetic field present, that is downward, and its value is b2. Particle enters at the point P perpendicular to Mn and leaves the point at Q perpendicular to Mn. In between it crosses this diameter here when it enters from this region to this region. Okay. So how to solve this problem? This problem is more geometrical than the problem of physics. Here geometry is more important. We have to understand that. So let's solve it. So to solve that problem, I have made this diagram. You can see the particle is entering at this point and leaving at this point. Suppose the particle enters at this point with the speed v naught. With the same speed it will leave it, because the force of magnetism, the magnetic force, is always perpendicular to the speed. So it cannot change the value of the speed, but it only can change the direction. Also we know by the law of physics that here your magnetic field is upward with b1. So this particle will revolve in a circular path, right? Because when the particle moves with the speed v naught and there is a magnetic field downward, sorry, upward, what happens? It will experience a force of q times v naught times b1 towards the center. So it turns its direction and this force is continuously acting towards the center. So if I just create the first circle here, you can see this is the central force, that is called the centripetal force. In this case, centripetal force is q v naught b1. From here we will get m v naught square by r by the circular motion laws. Suppose the radius of this first circle is r1, is equal to q v naught b1. From here we can find out the value of maybe r1 first. R1 is going to be m v naught square over q v naught b. So R1 is equal to m v naught over qb. In the same way we can find R2 for this one, because here the particle enters with the same speed v naught. Speed will never change. It is always v naught, right? V naught speed. It will never change. And here the central force is q v naught b2. So when we derive it, we will get R2 is equal to m v naught over q b2. We have to find out what is b2. From the first and the second finding, we can see that if I divide the first by second, I will get r1 by r2 is equal to m v naught q b1 divided by this, that will be in this way. So we'll get r1 by r2 is equal to b2 by b1. R1 by R2 is equal to B2 by B1. That means if I just find what is R1 by R2 in the term of B1, maybe we can find out what is B2. So let's find that now. So we have this R1 by R2 is equal to B2 by B1. And our target is to find out what is R1 by R2. So now let's look at this diagram here. I have taken this as a origin. Okay, and this point I have named because this is the origin and this is I'm taking as y-axis and x-axis, suppose. Then this point is going to be 0 comma something that I have taken h. This circle has the center somewhere here, suppose, so that is C1, and this circle has the center somewhere here, that is C2. Now we can find out what is the coordinate of C1, because you know that this length is R0. You can look at this bigger triangle here. If I draw it here, you will be more clear about it. This length was R0. This is theta 1. So this is going to be R0 sine theta 1. This is going to be R0 cos theta 1. So here you can see in this diagram R0 sine theta 1, that is this distance, that is the x coordinate of C1 in negative direction. And the y coordinate is going to be here to here, this length. This length is basically this total length from here to here minus this R1. So this total length is nothing but this, that is R0 cos theta 1 minus R1. So that is our y coordinate. So we got what is the value of the coordinates of this point C1. The point C2, similarly we can get the coordinates because this is R0, this length, and this is theta 2. So this length is going to be R0 sine theta 2, and this length is going to be R0 cos theta 2. So R0 sine theta 2, that is the x coordinate of this, and R0 cos theta 2 plus this length is the radius R2, that is the y coordinate of this point. So that is clear. Now one more thing that is very very important is when this particle enters from this region to this region, it will travel in such a way that it is tangent to this circle as well as on this circle. Because this is tangent to both the circles, so its radius will be perpendicular to this velocity. So this line and this line will be perpendicular to the same line, so that will be collinear. That means C1a and C2 are collinear. C1a and C2 are collinear. So this is going to give us a very very beautiful insight here. Because C1a and C2 are collinear, we can say that the slope of this C1 to A is equal to the slope of C2 to A. So I can say m of C1a is equal to m of C2a. What is the slope of C1a? H minus, I can write like this, H minus coordinate of this, that is R0 cos theta 1 plus R1, because we are subtracting, upon this 0 minus minus plus, it will become R0 sine theta 1 is equal to the slope of C2a line is, we can similarly find H minus its y coordinate, that is R0 cos theta 2 minus R2 over 0 minus R0 sine theta 2. Correct? This we will get. This relation is a very important relation, going to play a very important role. So here if I take this side here, we'll get H minus R0 cos theta 1 plus R1 over H minus R0 cos theta 2 minus R2 is equal to R0 of sine theta 1 over R0 of sine theta 2 negative. This and this get cancelled. Minus of sine theta 1 over. So we remember this relation is going to be used here. So this is if I say the 2. One more equation I can get from the equation of the circle. We know that the equation of the circle is x minus its x coordinate of the center minus plus y minus y coordinate of the center square is equal to the radius square. So equation of circles. First circle which is centered at C1. Its equation will be x minus minus plus r naught sine theta 1 whole square is equal to y minus r naught cos theta 1 plus r1 whole square is equal to r1 square. Now on this circle, this point lies 0 comma h. I can plug it here. That will give us r naught square sine square theta 1 plus h minus r naught cos theta 1 plus r1 square. Similarly, this is the third one. I can find the circle centered at C2, and at that circle also this point lies 0 comma h. If I do the same kind of thing, we will get r naught square sine square theta 2 plus h minus r naught cos theta 2 minus r2 whole square is equal to r2 square. Very good. So we got this third and fourth and second. I will use these three equations to solve what is r1 upon r2. So let's solve this now. So if you look at all this equation, first, second, third, fourth that I got, by 3 we can also do this, that we can take whole thing this side and we can write like this. By 4 we can take this whole thing this side and we can write like this, and then we can divide it. Now if I use the 2, you know that this upon this is sine theta 1 upon sine theta 2 negative, so square of that is going to be sine square theta 1 over sine square theta 2 is equal to r1 square minus r0 square sine square theta 1 over r2 square minus r0 square sine square theta 2. So I am just substituting the values. You can solve in other ways also by elimination or some other method. Just we have to solve these three equations basically. So here we will get, if I do the cross multiplication, we'll get r2 square sine square theta 1 minus r0 square sine square theta 2 sine square theta 1 is equal to r1 square sine square theta 2 minus r0 square sine square theta 1 sine square theta 2. You can see this and this get cancelled, and you will get r2 square sine square theta 1 is equal to r1 square sine square theta 2. So from here you will get r1 upon r2 is equal to sine theta 1 upon sine theta 2. So you will get now r1 over r2 is equal, is a square basically is sine square theta 1 over sine square theta 2. So r1 upon r2 is sine theta 1 over sine theta 2. But we know that r1 upon r2 is also equal to b2 upon b1. So from here b2 is equal to sine theta 1 upon sine theta 2 times b1. So that is going to be our answer. Now, so if you go to the problem and look at the option, there is one option here. So this option E is going to be a correct answer of this. This problem was really very beautiful, and it was geometrical derivation more than physics. I hope you will enjoy this solution. Thank you so much.